I'm going to cover the basics of problem solving for both individuals and organizations. That's frontline, technical leads, functional departments, and for managers. The basics of problem solving have to do with investigating and preventing a problem, which is what most people know as root cause analysis or incident investigation, but there are many other tools that people use. My name is Mark. My contact information is on the screen, and there's more information on our website at ThinkReliability.com. The individual as a problem solver is key. It's important to your organization. It's also important to your career. Your ability to solve problems is fundamental. It's part of what becomes a company's overall problem solving culture, and obviously ties in with their overall performance metrics. But how individuals think through problems, speak about problems, communicate problems, and obviously arrive at solutions, those concepts are important. So really we're going to cover up front, what is it that people believe? There are many different problem solving models and different tools and different terminology. There's a fair amount of confusion. We're going to cover the basics. We're going to step through really the method of problem solving, or cause mapping method, which is really just problem analysis solution. It is we'd say a scientific approach. It is fundamentally based on cause and effect relationships supported with evidence. That's how airplanes fly, it's how refineries operate, and it's how medicine works. Evidence-based medicine is the entire concept within healthcare. So what an auto mechanic does and what happens at a hospital, it is the same cause and effect approach. And then your ability to map problems and actually lead or facilitate investigations, either from troubleshooting smaller issues or conducting large investigations. That's really that career skill perspective. So we're first going to go through a little bit about what people believe. Now, there are some definitions in our cause mapping method that we think are important. When we say these are our cause mapping definitions, these are the definitions of the word. Analysis means to break down into parts. System is a combination of parts. And something that is complex, it means it consists of multiple parts. When you talk about a system and you say there's a combination of parts, a mechanical watch that someone has that's got all the pieces and parts in it, it's a system. You could say a respiratory system. You could say boiler feed water system. Systems used to describe many different things. But systems overall are a combination of parts. No individual part is the entire system. Every part of the system is required for the system to function. Just a pretty simple explanation of what a system is. It's a combination of parts that interact and function as a whole. If you look at what 50 years of root cause analysis has been, this is the conventional explanation, is the goal of root cause analysis is to identify the root cause of the problem. A lot of organizations believe this. A lot of individuals believe this. So one of the examples I'm going to use, these are common definitions that you can find from multiple sources, that a contributing factor or a contributing cause, very common language, it's a cause that contributes to the effect. On its own, a contributing cause cannot produce the incident. And controlling a contributing factor reduces the likelihood, but it doesn't necessarily prevent the issue. It's a common term that people use all the time. A root cause, however, is the main cause or the true cause or the primary cause. Sometimes we hear organizations use the true root cause. And a root cause is the main cause of the incident. Without the root cause, everyone knows the incident wouldn't have occurred. And if you control the root cause, it eliminates the problem. This is a very popular word, that it eliminates the problem. Now, if I ask you something about the fire triangle, which some of you may be familiar with, and some of you may have not seen it before. I know it's a tetrahedron, but here just a simple fire triangle. Fire requires an oxidizing agent. It requires fuel, which is a reduction agent, and it requires heat, which is activation energy. It's a reduction oxidation reaction. It requires heat, fuel, and oxygen. If I ask the question, is oxygen a root cause or a contributing factor of a fire? So I want you to think about that for a second, and then how you would answer it. Is oxygen a root cause or a contributing factor of a fire? And from asking this question numerous times, the most common answer is that it's a contributing factor. Almost everyone responds that it's a contributing factor. And then if I ask the question, well, if you say fire is caused by oxygen, fire is an effect and it's caused by oxygen, the question really is, well, does oxygen causes a fire? Oxygen causes a fire, true or false? Does oxygen cause a fire? And frequently people say false. They're like, well, no, there's plenty of oxygen in the room right now and it's not on fire. And I understand the point, so naturally people say, on its own, a contributing cause cannot produce the issue. So oxygen is obviously a contributing factor because oxygen on its own will not produce a fire. So check, oxygen is a contributing factor. But if you control only the oxidizing agent and not the heat and not the fuel, you still can't have a fire. Meaning the root cause is the one thing that if you control, you prevent the incident from occurring. If you control only the oxygen, you can't have a fire. So right now, oxygen meets the definition of a contributing factor and a root cause at the same time, because the fire triangle is just an example of cause and effect that says, oh, to have a fire, you need heat and fuel and oxygen. And the benefit of knowing that you need all three is that because all three are required, all three are necessary, they're all necessary to have a fire. That means if you control any one of them, you can prevent this fire from occurring. These two definitions are identical, and no one seems to notice it for 50 years, that that's simply the definition of a system. No part of a system on its own is the entire system, and the system needs all of its parts. In fact, if you control one of them, you're going to change the system. But this has gone on for decades, where people differentiate in companies between the important causes and the less important causes. And there are many discussions between frontline and management about what really caused the issue. Huge opportunity to change the way groups miscommunicate. And that's what's happening. Fire is caused by oxygen because the only thing this says is that oxygen is required. Oxygen is necessary to produce a fire. It doesn't say that oxygen is the only cause of a fire. If someone said, well, the flat tires because I ran over a nail, that's, in that particular case, that's true. The flat tire is because you ran over a nail. But there is more to it. It's just like if someone said we lost the Challenger because the O-ring failed. This statement is absolutely true. What it is not is complete. So this statement is true. Fire is caused by oxygen. It merely means that oxygen is necessary to produce that fire. Just like on the Challenger, the O-ring failure was necessary to produce the loss of the Challenger in that particular case. It's not the cause, though. It's simply a cause. The Titanic sank because it had an iceberg, but that's not the cause. That is a cause of the issue. And you can go through a variety of incidents where they're naturally explained with a single cause, or it's attributed to a single cause. And there's just huge confusion between whether something caused the problem or whether it contributed to the problem. And so you have to kind of challenge the language in your organization to say, what really are the definitions that our organization is using? Did we make them up, or are those actually the definitions of the word? And you can see from this fire triangle example, it creates a fair amount of confusion when you apply the definitions that many organizations use. And our cause mapping method, we try to explain that evidence-based cause and effect is not a tool that you pick from. It is the basis of a scientific approach. Understanding how to lay out a single cause and effect relationship is fundamental. If you connect several cause and effect relationships together, you can build a 5 You can build a 3Y or a 4Y or a 5Y. One of the criticisms of 5 Ys, and there are very strict adherents to 5 Ys that believe that the 5th Y is the root cause, which is not valid, but the idea of identifying multiple cause and effect relationships is a great idea. If you show how all of these connect together, it's what's called a chain of events. It starts out very simple and it expands, but you can have operations and maintenance and engineering and another group have a different explanation of the incident, but there is absolutely no contradiction at all. People think that 5 whys is not scientific because it's not repeatable, but a 5 why is not a complete explanation of the issue. You can have a 5 why that is absolutely accurate and evidence-based, but a 5 why is always a partial explanation of the issue. We have multiple examples online to show how an incident can start as a 3 to 4 to 5 why, and then it expands. But you can have 5 different points of view that all combine into one more complete explanation of the issue that builds into a 15 why. It can even get more detailed to a 20 or 30 why. It's just how much detail do you want to reveal. But the details are inside the problem. The details aren't from the tool or the method. The details are inside the issue. The logic of something like the Swiss cheese model says that, well, all these things have to align to produce the issue. And if you misalign one of those slices of Swiss cheese, you wouldn't have the issue. The Swiss cheese model is a perfect example of cause and effect because all of the causes have to happen to produce the issue. And if you change one, you couldn't have the issue. It is exactly the same logic as the fire triangle, that people think there's some unique relationship for fire, which is why all 3 of those things are required. The example for the Swiss cheese model and the fire triangle are not unique to the Swiss cheese model or fire triangle. They're both examples of cause and effect. But these metaphors almost confuse what fundamentally is going on within an organization. So companies are forfeiting an incredible amount of insight and ideas because details within problems are being miscommunicated between frontline and technical leads and managers. If you have groups that are biased between using terminology like what's the root cause and then they disagree, you can have 2 or 3 different people arguing about who is right. And that is not an accurate representation of the issue. That incident happened a particular way. And just because people are biased and only see their straight line linear point of view doesn't mean that it's complete. So it's just a huge opportunity and a change the way people communicate detail. So here's really what the steps of problem solving look like to us. So in our cause mapping method, this is what we've seen in a variety of organizations, that if you have a problem with your car and you take it to an auto mechanic, say your car is making a noise, that's a problem. When you take it to the auto mechanic determines what's causing the noise, which is the analysis step. That's what the mechanic would call troubleshoot. Like they're just going to troubleshoot the car and figure it out. The solutions the mechanic comes up with vary. The mechanic says, we can do this for $100, we can do it for $500, we can do it for $1,500. If you're going to, junk the car shortly because you've had it a long time, or if you say, no, I'm going to keep this car for 10 more years, it changes the way you solve the problem. And these 3 fundamental steps of problem solving, that you have to start with a problem, you have to go through the analysis, and you have to end up with solutions, are fundamental for problem solving, period. Even though there are a variety of different tools. Things like Six Sigma, which has its own acronym. It's a sound methodology. It is evidence-based cause and effect, excellent statistical tools. The acronym define, measure, analyze, improve, and control. Define and measure have to do with defining and measuring the problem. The 3rd step of Six Sigma is analysis, and the 4th and the 5th steps, improve and control, are about solutions. When you take something like 8D or 8 disciplines, it's an 8-step method. It still goes through problem, then analysis, then solutions. Under defining problem, it talks about the 5 W's and 2 H's. That's just what, it starts with who, but it's what, when, where, and then it's why and how much, which are just basic information gathering questions that are part of a problem, and it's part of even any journalism program. Basic information need, which is in step 1. The analysis is step 2, and solutions are step 3. Tools like Kaizen is a 7-step method that starts with define the problem, then analyze it, and then develop solutions. There are multiple problem-solving tools that sometimes companies teach, And then they talk about having a lean philosophy. And part of lean is removing anything unnecessary. And one of the waste items within lean is overprocessing. There is a fair amount of overprocessing happening in problem solving where companies teach 8 different tools, hoping that something sticks without just looking at basics of what's really going on. This is not to disparage any tools, it's to point out how everything aligns very cleanly from an auto mechanic to an instrument tech, to a nurse, to a pharmacist, to a doctor, to an engineer, to a scientist. It all lines up very clean because the problem solving steps stay the same. You have to have some specifics about the problem. So in our cause mapping method, we'd say you have to know the what, when, and where, and then you have to know the magnitude of this issue. You have to know the impact. Is it small, medium, or large? Is it something that did occur? Is it a near miss? You have to understand the consequences of this issue in step 1. And then analysis means to break down into parts. When you're breaking an issue down into parts, the chronology is an important piece of information, is the sequence of events. Cause and effect is fundamental to problem solving. If you're going to change outcomes, meaning you're going to produce solutions that produce different effects, you must go through a cause and effect analysis. The chronology is absolutely when things happen in a certain order, and the causality is why and how. So the scientific method is based on cause and effect, or the repeatability that is the requirement within a scientific approach is to demonstrate that these causes produce these same effects. It's fundamental for medicine, it's fundamental within a power plant. It's also what the auto mechanic does, and it's what the farmer does. It's the basics can't be skipped. So a timeline is an excellent tool. It's one way to break things down into parts. The chronology is important. It is separate from the cause and effect. Once you understand cause and effect, and you're identifying changes to prevent problems, that is really where the solution options come in to say, you know what, there are different ways to solve this problem. That is what highly reliable organizations are doing, are looking at how do we mitigate risk. There really are degrees of problem solving. A bias that a lot of people have is what's the right answer? And there isn't a right answer to the problem. There are solutions that in combination can mitigate risk. That's why there's something called layers of protection and defense in depth that produces a cumulative reduction in risk. It's why vehicles have seatbelts and airbags and anti-lock brakes and crumple zones. It's a combination of things that mitigate risk in a complex system, meaning it's got a lot of parts. So pretty simple, there are 3 steps. If you really think about how this looks, and it's part of our ThinkReliability approach, is that you have to understand why your problems happen. Tools like 5Why are an excellent baseline because it's just a starting point. But cause and effect is fundamental for anyone troubleshooting equipment, working through a human performance issue, understanding safety incidents. It doesn't change. Cause and effect doesn't change from incident to incident or industry to industry. It is a principle. It's not a tool that you pick from. It is a baseline principle of all problem solving. Once you understand cause and effect, it says, oh, well, then we could reveal where our work processes broke down. So if you understand why your problem happens, you can identify solutions to prevent those problems from occurring in the future, meaning you fix your work processes and then it prevents problems from occurring in the first place. So this is, what is happening if there's an aviation issue, then the NTSB investigates that incident, identifies solutions, makes recommendations through the Federal Aviation Administration, and there are solutions to prevent that from happening. The fixes aren't with the single airline that had the issue. The fixes are in work process across industry that affect all airlines. So while it starts off looking fairly reactive when you have a problem, the whole idea is how we become proactive. That's how individual incidents turn into lessons learned that become best practices in a company. The overall big picture is there are fundamentally processes, work processes in your company, and when they don't go well, it is a problem. This is basic, fundamental across industry. There are tasks happening in every organization, whether flying planes or delivering medication, installing a piece of equipment or delivering a product. There are a variety of different tasks that involve people performing those tasks. Some are automated and there are equipment, but people have to install and maintain that equipment. So even if something's fully automated, it still involves people. So there are processes in your organization. When they don't go well, it's a problem. This is fundamental to the classic quality cycle or improvement cycle that says plan, do, check, act. It's just your processes are what you're doing. You measure results from that process, which is check. If it goes well, you would just continue to do that work process over and over again. If there is an issue from where you check, you have to take action and figure out why that problem is happening. And what comes from that problem is the new plan that fixes your process. That is really the cycle. We found it much easier if people understand that we have work processes, and when they don't go well, it's a problem. It's as though the problem is just a signal or an indicator that your work processes broke down. If your work processes are going well, then you continue to do it without incident repeatedly. When there is an issue, you have to figure out why. Those 3 steps of problem solving fit here: problem, analysis, solution. You have to define the problem and know the consequences, the impact of goals. You're going to start with simple cause and effect, and then you have the option to identify solution options, just like the mechanic, and pick those best solutions. If you look at how this fits in, problem solving tools like A3 and 4-block and 5 Whys and 5 Ws plus 2H and 6 Sigma and 7-step and 8D and quick wins and Fishbone and brainstorming. Like, brainstorming is definitely a problem solving tool. It happens in the solution step. You're not brainstorming the analysis, you're following the evidence. The analysis is evidence-based cause and effect. If you're having people think up every possible cause of the problem, it's missing the concept of what a scientific approach is and spending way too much time speculating without gathering evidence first. You shouldn't even really be in the meeting unless you've collected evidence first, because it's not the best use of time. Tools like the Swiss cheese model and barrier analysis are all fundamentally cause and effect. Everything related to process, whether it is a process flow or process map or value stream or 5S, it all has to do with making that work process go better. And then the connection between these two is the overall Schuhart cycle, quality cycle, Deming cycle, what overall is called the Kaizen approach of continuous improvement or problem prevention. But again, this is not to point out that there's confusion. It's to say these tools all align fundamentally, that there really are processes in your organization, and when they don't go well, it's a problem. The confusion comes up when organizations teach multiple tools, thinking that it will make it clearer if we give people more tools, and it seems to create a fair amount of confusion, because what is basic cause and effect is why I went through the fire triangle example on how many issues are miscommunicated and how many organizations think that the end of an investigation is procedure not followed, human error, or management systems, and really not understanding how do some organizations perform tasks with thousands and sometimes millions of iterations without incident. What is it that they're doing? And it's really that HRO, that highly reliable organization perspective, is just a huge opportunity to make things simpler. So here's really how it connects for us and our approach is there are small, medium, and large problems in your company. There are small problems, medium-sized problems, and large problems. Your small problems, whether they are safety, environmental, customer, patient safety issues, operations, schedule, production, equipment, regardless of the type of problem, you can start with a basic cause and effect analysis. It is going to stay, because it's a small problem, fairly basic in terms of cause and effect. If it's a bigger problem, it is still going to start with 1 to 3 to 5 why questions. It's going to start basic cause and effect, but it's going to expand into 10 or 15 if needed. If it is a large incident, it still starts with 1 to 3 to 5 whys. It can expand to 10 or 15 or 20, and it can expand to 50 or 60. Because the incident has all of the detail in it. There's not an investigation method. People tend to think that the investigation tool provides the structure. The structure is already in the incident. That is what is different about a scientific approach. People think all these tools will provide the structure to the incident, but the incident already has a structure. An atom already has a structure. The solar system already has a structure. scientists explain what that structure is through observation and measurement and testing and experiment. If you ask why questions, you don't know the answer. That is the basis of a scientific approach, because you have to follow the evidence, and you have to, in your organization, you have to talk with people. You may have to set up an experiment or a test to prove or disprove, to demonstrate results, just like they do within healthcare. If they're testing a new medication, you have to demonstrate cause and effect in terms of results. Whether it's a new medication or new procedure, it's the same way on your equipment, your systems, your safety issues. It's the same thing. The whole idea of establishing a 5 why baseline is, regardless of the type of incident, it can start very basic. This means frontline problem solving is the huge opportunity in an organization because it engages the frontline people. They are part of that problem solving effort. This is why things like our 5 why COSMAP starter page is such an easy way to begin. It's super simple, basic information, a few why questions. It's a simple sheet of paper. You can use it on a clipboard, very basic. On larger investigations, our cause mapping template that we use in Excel is just something you can download from our website, and we have examples of how you can start with a rather simple issue, and it expands into much more detail. The point that I wanted to make is no organization wants these great big issues. They don't want any of these large investigations that we do. When there is a large investigation, invariably you find out, well, this had to happen, and this had to happen, and this had to happen. All these things had to happen. And while we're going through that investigation, occasionally frontline people say, well, that thing right there that had to happen, which, remember, this is the Swiss cheese model of saying all these things had to happen for the incident to occur. So the Swiss cheese model is just a great example of cause and effect. All these had to happen. That means that frontline person is telling us, oh, that thing right there that had to happen, you're telling me that if we just did that, we wouldn't have had this issue? They sometimes point out that, oh, I could have told you that 18 months ago, meaning I knew this was an issue 18 months ago. That means that issue 18 months ago was a 5 why or a 3 why, but we didn't address it as that nuisance issue 18 months ago. It's now part of a much larger issue, which, with a bunch of other things, all contributed to the issue. That work process that was broken 18 months ago could have been found on a much smaller issue. That's why hindsight is 20/20. So when you talk about the incident triangle from 100 years ago, these smaller problems here are the opportunity for the frontline people to say, oh, they see things a lot earlier than everyone else. So the closer you move problem solving to the front line and actually improve the way management, technical leads, and the front line communicate detail, the better your organization gets at preventing incidents from occurring in the first place. That's Heinrich's original triangle from almost 100 years ago. So if you want to learn more about this approach or understand our 5 why COSMAP starter page or our full cause mapping investigation template, don't hesitate to contact us or visit our website. Thanks very much for listening to us, taking the time to go through. If you have any questions, you want to see some of the examples of the 5 whys of the different types of incidents we do, they're going to be listed here on the website. So thank you. Don't hesitate to contact us if you want an example, and please comment below if there's any part of this that you'd say I kind of challenge, or I would say it's not the model, it's not what I'm used to seeing. Please put them in the comments below, and we appreciate your feedback. All right, thanks very much.